Okay. Hello. Before we start, since this is the first video, I want to start with introducing myself and also talk about LearnIt for a bit. Hello, my name is Ken, and I am a high school student as well. I have a passion of physics and also of teaching. So it's really great that I'm able to do both in this project. Um, First, you might question, why is it called Foundation 1? So basically in LearnIt, there's three levels. So we basically start from foundation, and then you start to medium, and then you go to advanced. And basically, foundation is in short junior high school or grade 8, grade 7, or grade 9. And medium is more to grade 10 physics. Advanced is grade 11 and 12 physics. So if you're familiar with the curriculums, sorry, yeah. So make sure you watch with in accordance to your level. But if you want to step up, it's completely fine as long as you enjoy it. Um, so first, let's define what forces is. Right. Oh, sorry, I forgot to introduce. Um, in this first topic, we will talk about forces and Newton's law. In the next video, I'll cover forces and Newton's law again, but for medium level. Okay, so what are forces? So forces is an influence an object has due to an interaction with another object. So we should take the keyword influence and interaction. So what we can deduce is from influence, it's a push or pull. Push slash pull. It's a push or pull factor. For example, I can push the mouse around or I can pull it. The fact that my interaction with the mouse causes the mouse to move, it is a force. And I'll explain more on that later on. But for now, let's talk about this. So there are two main points of forces for now. First of all, this is the unit of forces. It's an N. So N stands for newtons. So this is newtons. Newtons. And why is it called newtons? Well, in short, the person who discovered forces or gravity or calculus, you might know, is Isaac Newton. And it's kind of a tradition in science to put your name in your discovery, your inventions and things. So basically, it's measured in newtons, and so you have an answer in the test. After a calculation, you calculate the force. For example, 300, always put Newton. For now, at least. There's more units in dimensional analysis, but in foundation, we'll not cover that. So you're safe with just N. So second is force equals to MA. So what MA means is basically M multiplied by A, M times A, same thing. But we might want to question what M or A is. So M, in simple, is the mass, and A is the acceleration. Okay. So just memorize this formula for now. Memorize that we will also use newtons in any calculation because you'll need it to apply it on the next materials. Okay, so let's move on. Okay, say I have an example. Object A and object B. This person right here is pushing the object. So from the previous keyword, we can say that the person is exerting a force because a force is a push or pull factor, right? So the person is exerting force on the object. But in object A, there is no force exerted on the object. Okay. However, the object is exerting a force to the ground, but to the object there's no force. There's actually a normal force, but I'll cover that later on in the video. Next, Newton's laws of motion. Okay, so Newton again. So there's three things that we generally need to memorize from Newton's laws of motion. It's pretty simple. I'll start with the first one. An object will remain at rest or move at a constant velocity unless acted on by resultant force. So what this basically means is that any object you has, let's say object A, since it's not acted on by a resultant force, any force, it's not gonna move, or it's not gonna change the speed. And currently the speed is 0, so it's not gonna move. And you might wonder what resultant force is. So resultant force, basically if you were to have an object pushed by the force of, let's say this guy again, he pushed this with a force of 5 newtons. And let me attempt to draw another person. This guy's also pushing it. Okay, let's say they have very long legs. This person is moving it. Sorry, attempting to move the object at a force of 200 newtons. Let's say. Now, since force has direction, as it is a vector quantity, if we want to know how much force is actually applied to the object, we need to sum all of them. But before we do that, let's assign the positive and negative. So you can basically choose on your own, but there's no right and wrong. But generally, I like to put the one going to the right as the positive one. Again, you can do the other way around. Doesn't really matter. And this is the negative one. So if you were to sum up all the forces, so Fr, R is resultant. I use R to identify each of the force variable, because if you put F equals to F plus F, it's a bit confusing. So Fr, it equates to 500 subtracted by 200. Right? Subtract because this is negative. Yeah, so that's resultant force. So I remember that if there's more than one force exerted on an object, don't forget to sum all of them. And also, actually, one more example. Let's say there's two personnel, one tiny person. Let's say his kid. If he is applying 500 newton, let's say the kid is applying 50 newtons. Since it's going on the same direction and it's both positive, you can simply add 500 plus 50. So Fr equals to 550 newtons. Okay. So just remember that if it's contradicting each other, make sure to subtract it, basically. So these are the other law. Let's start with F equals to ma. We discussed this already. It's basically force is equal to the mass multiplied by the acceleration. Next, every action has an equal and opposite reaction. Okay, so this brings the concept of normal force. So first, if an object is laying on the ground, it is exerting a weight force. Weight. So a normal force will be the exact same. Basically, it's what's being applied back from the object, N. So we'll have the same exact direction and the same exact magnitude. Hence, you can equate this using N equals to negative W, or N equals to negative force applied or anything. Basically, this is the reacting force. F react. Sorry, the pen is really thick. The word force is force acting. Force act. Right? Um, you don't do much. You don't need to know much deeper. For the foundations, I'll discuss this more in advanced um, physics. So next, let's start with the questions. Right. Um, First, when the mass of the block is 500 kilogram, how many force is needed for the block to accelerate at 50 meter per second squared? Uh, of course, every time you encounter a question, make sure to list down all the variables. So first, m is equal to 500 kilogram. Then a is equal to 50 meter per second squared. And because we might think we see m and we see a, what this reminds us of the great equation: force equals to mass times a. So from this, you can just plug it in the formula. So force equals to 500 times 50. Force equals, so the force, it equals to 35,000 newtons. Don't forget the unit. Okay, let's go on. Next question. Also, should have probably reminded you, but you can pause the video to do the question by yourself if you wanted to. What will happen to the person when the person sorry, what will happen to the object when the person stops exerting force? So since we now know that the F is 0, according to the first law, an object will remain at rest or move at a constant velocity when the resultant force is 0. Basically. So if it's 0, oh wow. Sorry. Eh. Okay. When F is 0, and we know we have a mass, right? Because it contains mass, that's for sure. Then what could be 0? Well, F equals to m times a, right? So a will be 0, according to the first law. So what will happen to the object when the person stops exerting force? Well, there's few interpretation, but one, you can say that the velocity is constant, and two, you can say that velocity is 0, or object stop moving, basically. But since blocks doesn't really have wheels, let's say the ground does contain friction, the block will probably stop moving, right? But that involves the laws of conservation of energy and also friction force, which I will only discuss in medium physics, medium or advanced. Okay. So, question 2. So person A is pushing the box at a force of 200 newtons. So let's write this down. This is 200. Oh, sorry, did I say 400 before? I meant 200. While person B is pushing the box at a force of 500 newtons. So let's differentiate the colors. This will go here and 500 newtons. Okay, so A, determine the force exerted on the object, total force, the net force, right? So again, as I thought before, yes, let's try to assign this the positive again. So 200 will be subtracted by 500, right? But you might think, oh, the answer is negative. Does it mean there's no force? Or does it mean I'm wrong? No. So since this equates to negative 300 Newton. Remember how we assigned this to be the negative one? So since it's negative, we can say that 300 is going in this direction, the negative direction. Because there's a positive force, negative force. We can say that 300 is going on the negative direction. Okay? That's it for the question. Oh, sorry, that's a B. I forgot. Next one. If the mass of the object is 200 kilogram, what will be the acceleration of the object? So 300, negative 300 is equal to 200 times acceleration. Times acceleration. And the acceleration, that will be negative 300 over 200. Okay? Okay. So that would be negative 3 over 2, negative 1.5. Wait, does it fit? Let me. Here. Okay. Negative 1.5 meter per second cubic. Square. Okay. So you can take notes of this. I should probably write down that the reason this is 300 over 200 is because I rearranged this to be the force over the mass. So it'll be 200 over 300. Okay. So let's go on. Last question. Okay. If an object's mass is 500 kilogram, what is the normal force exerted on the object? Well, pretty simple. I think we did basically the same thing before, but since this is applying weight, so weight force. So actually, another thing I should explain is that weight in physics is equals to the force that an object is applying to the ground, basically. You can say that, in real life, people just say, my body weight is 50 kilogram, or my body weight is 70 kilogram. But weight in physics is actually the mass, which is the amount we actually usually say. 70 kilogram is my mass. It's not my weight, it's my mass. So weight is actually the mass times gravity times g. So if I were to say that let's say this is me, not very accurate, but let's say my mass is 70 kilogram, and because the acceleration downwards, because gravity is 10 meters. Yeah. Sorry for the bad handwriting. Also, it's usually 9.8. We should know that. But for simplicity's sake, you can usually round up to 10. But do verify what the question asks you in exams, because in exams, usually they specify, use G as 10, use G as 9.8, and so on. So here, my mass is 70 kilogram and gravity is 10, then my weight is 700 newtons. Right, I'm applying quite a lot of force. And maybe you heard that you'll be heavier on a different planet or lighter. Well, that's true because the gravity is different, right? So if you were to go on a different planet with, let's say, less gravity, then you'll be technically lighter in that planet. Okay? But it's not really relevant now. I don't think you need to know this as much. But actually, those types of calculation, weight and mass, is often asked in grade 8 physics. So if a person has an body mass of 70 kilogram, what is their weight, and so on. Or you will be asked to differentiate the difference between mass and weight. Okay? So enough of that. Let's start counting. So based on this information, since, sorry, since the mass is 500 kilogram, and the acceleration is 10, so the weight force, you could say that's 5,000 Newton, right? So it's applied 5,000 here. And as I explained earlier, normal force is basically what the ground is giving back. It's 500 newtons. Because notice how the box isn't moving through. The box isn't sinking through the ground, right? It's equilibrium, it doesn't move. That means that the resultant force is zero. Because it's in total equilibrium, the V is zero, the A is zero. So the force exerted is also zero. So that's how we know that it's a balanced system. But as far as I know, for junior science, you don't necessarily need to know this, but it's good to know because you can visualize things better. And yeah, that's actually it for introduction to forces. So thank you so much for watching this video. I hope it's very informative. If there is any feedbacks, you can reach out to me in the Google Classroom. That will provide the link, or you can email. And yeah, thank you so much.